Hi, ladies. Today we're going to continue practicing some of the strategies and skills that we practiced last week, going a little bit further into how much greater or how much less a place value is than another place value, or how much greater one 5 is than another 5 in a different place value. So our learning target today is I can understand place value relationships. We are focusing on page 9 in your packet right now. So if you're not already on page 9, please make sure that you get to page 9. And we're going to go through this first page and do some examples together. So in this top portion that's labeled vocabulary, you'll see that there is a place value chart with a digit in each of the different place values. So how we read this number is 640,409,210. So how we are going to be working with this today is we're going to be talking about expanded form using just whole numbers as well as expanded form in powers of 10. And then we're going to be talking about some of the different place values and how they relate to one another. So the number name for this number, so number name is how we read it, so kind of that word form. So it is 600, and I'm right here at the top, it is 640,409,210. And we're going to be looking at number 1 at that expanded form. So expanded form is a way to write a number as the sum of each digit multiplied by its place value, okay? So we're going to fill in the blanks to write the number in expanded form. So looking at this first part, so this is where we're going to, instead of talking about the expanded form using exponents, we're going to be using just those whole numbers right now. So we're going to be multiplying by 10, 1,000, 100, whatever it is, whatever the place value is. So right now we have the 6, and if you look up at the top, the very first number in the 100 millions place is a 6. So what we're going to do is we're going to replace this 6 with a 1, and then we're going to turn everything behind it into a 0, okay? So this is going to be representing 100 million, and if we take 1, multiply it by 6, it gives us 6, and then everything else would turn into a 0. So this number is going to be 100 million. So then if we move on to the 4, we're going to be doing the exact same thing. The 4 is in the 10 millions place. This 4 is going to turn into a 1. And then everything after the 4 is going to turn into a 0. So 4 is in the 10 millions place. So we're going to be writing 10 million on this line next to 4. Okay, so if we took 4 times 1, that gives us 4, and then everything else stays as a 0, which would give us this value of 4 10 millions, or 40 million. The next 4 is in the 100 thousands place. So we're going to replace that 4 with the digit 1. And then everything after it is going to become a 0. This is the 100 thousands place, so we're going to be writing 100,000. And then exactly the same, that 4 times this 1 gives me 4, and everything else becomes a 0. The 4 in the 100 thousands place represents 400,000. Let's go to this 9 in the 1 thousands place. The 9, we're going to turn into a 1. And then everything after it becomes a 0. But then think, so 9 1,000s is going to be the same as 9,000. And if I take 1,000 times 9, I get 9,000. Next, we have a 2 in the hundreds place. That 2 in the hundreds place represents 200. So in order to get 200, we're going to need to take this 2, turn it into a 1. Everything else becomes a 0. 2 times 100 gives me 200. And the 2 in the hundreds place represents 200s. And then lastly, we have a 1 in the tens place. So that 1 in the tens place, we're going to keep it a 1 because the value of that digit is a 1. So that stays a 1. Everything else becomes a 0. 1 times 10 is 10, and right now we have 1 stick of 10. So this is how you would write it out using expanded form, using the number form of kind of that those exponent examples. So now we're going to be looking at how we can write this using exponents instead. And remember in yesterday's lesson, we talked about how the 10 is what we're multiplying. The exponent tells us how many times we multiply it. So basically, however many zeros these numbers have is going to represent our exponent. So looking at this first one, change my font size. Looking at this first one, we have 6 times 10. So 6 times 10, but we want this 10, this exponent, to represent the place value. And in order to represent the 100 millions place, we need to have 8 zeros, okay? Because it's a 1 with 8 zeros behind it, as you can see up here. So down here, our exponent is going to be an 8. So then next one, we have 4 times 10 to the power of something. And same thing, we want to represent the power that we're talking about because the 4 times 10 million has 7 zeros. So 10 to the 7th represents 10 million. So we'd put a 7 in that exponent spot. Last one we're going to do together on number 2 is this next part right here. So we have 4 times 10 again. So we're talking about the 100,000th place right now. So in the 100,000th place, if you notice, our 100,000ths has, or thousands, I'm sorry, 100,000s has 5 zeros. Okay, so we want to represent this 4 times 10 to the 5th power because 10 to the 5th represents 100,000. All right. So now I'm going to have you finish numbers 2 and 3 on your own. We're going to go down to number 4 and talk about number 4 together. So on number 4, it says the first 5 in the 100,000s place, or is in the 100,000s place, so what is its value? Okay, and remember we talked about how the value of a digit is, so we have that 5 in the 100,000s place, and then everything else after it is going to become a 0. So right now, the 5 right here in the 100,000s place, we're going to have this 5 turn into a 0, and then everything else after it becomes a 0. So 5 in the 100,000s place is going to represent 500,000. So down below on the next part, it says the second 5. So our second 5 right here in the 10,000s place represents the value of what? So again, that 5 stays the same. Everything after that 5 becomes a 0. The 5 is in the 10,000s place, which represents a value of 50,000. So now we're looking at how the value of the first 5 and how the value of the second 5 compare. So how many times greater is 500,000 than 50,000? So basically what we're going to do is we're going to see how many place values apart they are. So if I line them up like this, how many place values apart are they? Are they 1 place value apart? Would I need to move this 5 1 time in order to make it 500,000? Do I need to move it more than 1 time? However many times you move it, that's going to represent how much greater it is. So each move is multiplying by 10. So if you notice, we're only moving 1 place value. So that 1 place value is going to be representing that it is 10 times greater. Okay, so that value of 500,000 is going to be 10 times greater than 50,000, because if I take 50,000 and multiply it by 10, that's going to give me 500,000. On number 5, it says write this number in expanded form using powers of tens with exponents. So that is going to be exactly like question number 2. So you're going to take each digit. So you would start with your 4. You would multiply your 4 times 10, and then you're going to figure out what your exponent would be for that 10 based off how many place values are behind it. So you have 1, 2, 3, 4, 5, 6. So you would want to make sure that you put your exponent as a 6 to represent the 4 in the millions place. So then after that, you are going to be adding that to our next digit, which is 7 times 10, and so forth. You're going to, again, add your exponent. The 7 is in the thousands place. In the thousands place, there are 1, 2, 3 digits afterwards. So then your exponent here would be a 3, and then you would continue to add. Okay, so you can use number 2 as a reference for number 5. So let's go to the next page. The next page is page 10 in your packet. This is going to be the other part of your assignment that you're going to be completing. We're going to look at number 16. It says, Paul says that in the number 6,367, 1 6 is 10 times as great as the other. Is he correct? So the first thing that we want to do is we want to figure out what the value of each of these 6's are. So if we're looking at that, so look at this 6 right here in the thousands place. So that 6 stays a 6, and then everything else becomes a 0. So that 6, the value of it is 6,000. And then if you're looking at this 6, the value of that 6 is in the tens place with 1 0 behind it is 60. So if I line these up, we want to figure out how many place values I would have to move in order to go from 6 in the tens place to 6 in the hundred or in the thousands place. I'm sorry. So from here to here is 1 time, and then from here to here would be 2. So each of these jumps represents a to multiply by 10. So let me kind of show that a little bit better. So from this 6 here is going to be 1 jump. And then from here to here is going to be 2 jumps. And each of these jumps is me multiplying by 10. Sorry, this is really hard to do. Is me multiplying by 10. So to go from 60 to 6,000, I actually have to jump more than 10 times. I have 2 zeros here, so this combined is going to be 100. Okay, so 6,000 is going to be 100 times greater than 6. So 6,000 is 100 times greater than 60. So if you look at this and we solved it out, if you take 60 and multiply 100, that's 6 times 1 gives me 6, and then you have 3 zeros that you have to add. So if I only multiplied by 10, then it would be 6 with 2 zeros. So he is not correct because he actually needed to multiply by 100 because 6,000 is 100 times greater than 60. So he is incorrect. And then the last one we're going to do together is number 17. So on number 17, it says George drew a square that had a side length of 8. So he's going to draw his square, and his square has a side length of 8 inches. Okay, so one thing we want to remember about a square is a shape that has 4 equal sides. So if we know one side, we know all of the sides, okay? And we're trying to find the perimeter. And on page number 4, on page 4 in your packet, there's a resource about area and perimeter, and it shows that the perimeter is us measuring the entire distance around the shape. So we're adding together. So it's basically length plus width. And that's going to give us the perimeter. In this case, because it's all the same, I can either do 8 plus 8, plus 8 plus 8, and that could give me my problem. Or we know repeated addition is another form of multiplication, so I could do 8 times the 4 sides, which would also give me the same answer. So on this one, you want to go ahead and solve. Make sure that your answer has a unit of inches. All right, so your job today is to continue with the last few problems that are on your paper on both pages 9 and 10. And then for your additional homework practice, you are going to be completing today's quick check on Pearson Realize. So it's going to be labeled as 4-7-20 quick check. So you'll be completing that as well. Again, if you ever have any questions, please feel free to reach out. We are going to be meeting on Zoom on Friday at 11 o'clock. So if you have any questions that you would like answered, you can actually, we'll probably be meeting on Thursday because Friday's Good Friday. So I'll get back to you on that. But make sure you bring any of those questions with you to our next Zoom meeting. And if you did not receive information or the login for any of our previous Zoom meetings, please reach out and we'll make sure that you get those. Because they're super fun and you get to see your friends and ask questions and stay connected. So if you have any questions about any of these assignments, please feel free to reach out. Have a great rest of your day, ladies.